All right. So for this next one, we are now going to be calculating, using functions, the abundance of each of the individual plants, species, that we saw in our plots. So in order to do this, abundance is going to be a percentage. We're going to use decimal points though. We're not going to use percentages, which is fine. I'll show you how to interpret that when we're done. But we're going to be calculating that. So it's a percentage. And anytime you do percentage, it's out of 100%, out of a whole sample. So our 100% would be our total number of individuals. And what we do to calculate percent is we take the number of any individual species and then simply divide it by the total number of individuals in the plot. So how we're going to do that using the spreadsheet functions is we are going to put our open up the cell here, and the cell for this one's going to be D5 because we're going to be calculating up to percent abundance of Himalayan blackberry. And then you're going to open that cell and you're going to type the equal sign, and then it is the number of individuals of that particular species, this being Himalayan blackberry, so 5, or cell B5, right here, cell B5, divided by cell B12, the total number of individuals. And again, we're entering in the cells, not the numbers. So what you have should look exactly like this. Then you're going to hit enter, and you're going to get a decimal. Now we could change this to be a whole number, but with percentages, I prefer us just to keep the decimal system. If you move the decimal over 2 places to the right, you'll see that this is basically 1.2%, which sort of makes sense. It's a very small percentage of that was Himalayan blackberry, only 5 out of 415. So that makes sense for that. Now we can do that same function for this one. So we could type in equals, and this cell here would be B6 divided by cell B12. But I'm going to show you guys a little trick here to make this that much simpler. So we could drag this function down, but in order to do that, we need to make sure that these cells here change, while this cell down here remains constant. So in order to do that, we are going to put our cursor up here, in between the B and the 12, and we're going to add in this symbol here, and it's a money sign. After we've done that, it should say equals B5 divided by cell B12, but B has the money sign and then 12. Now you may be wondering why I'm doing this. I'll show you in just a second. So then you hit enter. You still get the same number here, but now we can highlight the cell, and where the little blue box is here, we're going to grab it with the little plus sign, hold down, and we're going to drag that down for all of the cells that are green right here, and then let go. Now it's done that calculation for each of these cells then, so the percent abundance of each of these, and obviously it's 0 where there's nothing over here. Now if you look at it, cell still says B12, but cell, instead of being B5, it changed to cell B6. If you click down here, it's now cell B7, still divided by cell B12. So what adding that dollar sign does in here is it makes this remain constant while the top number changes. So this should then equal the total of 100, or 1 in this case, and that would be 100%. So we've got about 96% of our plot was reed canary grass, and about 2%, 2.5% was the sedge, and then only 1.2% was the Himalayan blackberry. And that makes sense. Now you may have a long string of numbers here, and it may look something you may look more like this. What you want to do to reduce that down to just 3 decimal places is go over here and put your cursor on where it says next to the percentage, the 0.0 with the little arrow. It says decrease decimal places, and just click on that, and it will decrease the decimal places over here until you get to 3. And you could highlight all of yours and do that all at the same time if you wanted. Now that we've calculated that out, we can then copy this like you did before up above and paste it down into here, like we did on that last unit, I guess I would say. So for this, you're going to select this cell here, cell D5, and then Control C to copy it. And now you're going to select the cell, similar cell in the different table, and hit Control V to paste it into here. You have to correct something now, though. This is very important. You stop and really pay attention to this. If you look at what it says in this cell here, over in the function bar, it says that this cell is equal to B19, so this right here, which is what we want, divided by B12, and that's this up here. So we have to change it to being the total number of individuals in sample plot 2, because this keeps it constant. So all we're going to do is change this to be, instead of B12, to be B, what is this, right over here, 26. So we could go up here and just change that to B26. Enter. Okay. And double check it over here. B19 divided by cell B26. The money sign there. So that remains constant. Now you can grab this cell with the little plus sign here, drag it down for these. Should be good to go. Look at that. Okay. Oh, accidentally selected an extra one here. Look at that. I did not mean to do that. So now I can just hit delete there and get rid of that one. Okay. Now we've got everything we need there. Oh. Now I'm going to do the same thing here. Copy this one. Move it down to my next sample plot, paste it, and again I'm going to have to correct it because you can see now that I've pasted it, it's B33, which is B33, divided by B26. Nope, I need to divide it by the total number in this sample plot. So I need to correct this last one here, B26. It needs to be B40 right here. Okay, so then change this to be 40. Correct. Grab it. Drag it. Okay. So for this one, just looking at our data, we have moved the decimal over 2. We've got 2.4% for Himalayan blackberry, 1% bedstraw, which is a native, about 1.5% sedge, and again about 95% reed canary grass in here. So just looking at our data for our last few plots, reed canary grass is dominating. It's 96% here. Move the decimal over 2 places, 92% there, 95% there. This will really show up when we graph this as well. You'll be able to see this, but already you can kind of see what your data is telling you. Go ahead and do that same process for tables, sample plots 4 and then 5, and then you've calculated out your total abundance for each of your plots for each of your individual species, and we are good to go there. All right.